The history of music and mathematics goes back 2,500 years, all the way to Pythagoras and Plato. In fact, our understanding of music depends upon mathematics, such as durations are given as fractions, half note, quarter note, eighth note, etc. Tonal functions we give with Roman numerals, such as 1 and 5, and we measure musical intervals with integers. All of these things make a musical system, and composers compose from musical systems. And from around 1650 to 1900, all music in Western civilization was composed from a single musical system. The masters, such as Bach, Beethoven, and Brahms, not only expressed their hearts and their souls through this system, but used their minds to control all the intricate details of this mathematics. They were very much aware of what they were doing. Beginning around the 20th century, composers began to experiment with new musical systems. Some composers would create a single musical system and then write all their music from it, while other composers would create a new musical system for each new piece they composed. Considering this rich history of music and mathematics, and that composers make musical systems from which to compose, led me to consider the question, how might pi sound if it were implemented in a musical composition? I'm going to create a musical system from pi and then share with you a piece that was composed from it. When two notes have fundamental frequencies that are related by the ratio of 1 to 2, we call it an octave. It is the most simple interval we have in music. They are so close together that we give them the same letter name. In this case, two A's are related by an octave. There are 8 A's on the piano keyboard, and each one of them is a different pitch. However, we apply equivalence to them and say they are all equivalent through octave equivalence, so they are members of a single pitch class, A. So an A in a specific octave is a pitch, but an A in any octave is a pitch class. There are 12 pitch classes in our musical system. Music theorists label them 0 through 11, so we could measure the distances between them. A piano keyboard has a repeating pattern of 7 white notes and 5 black notes that spans the whole length of the keyboard. The low frequencies are on the left-hand side of the keyboard. The high frequencies are on the right side of the keyboard. As you ascend, the pitch rises. But the repeating pattern of 11 pitch classes repeats over and over again. So it's like a spring. As you go up on the spring, the pitch rises. But at the same time, you're going in a circle around pitch classes. And so that gives us this thing on the right, the circle. It's called a pitch class wheel. It's essentially like a clock, except the 0 is replaced with a 12. It's a tool that music theorists work with. Now I have a circle. Now I can start talking about how pi integrates into this. Pi is the ratio of a circle's circumference to its diameter. It is a little bit larger than 3. It's an irrational number. If I take the pitch class wheel and start with 0 and move clockwise around it, the distance of one diameter, it falls somewhere in between 3 and 4. It is closer to 4 than it is to 3, so I'll round it off to 4. And if I start there and move around the circle again, another diameter, it falls in between 7 and 8. It's closer to 8 than it is to 7, so I'll round it off to 8. As I keep doing this, I get a series of pitch classes. It sounds like this. It keeps going, it doesn't stop. Now what about the rhythms and durations? I can apply the same concept to them. I could say that the circumference of the circle is equal to a specific duration in music. In this case, a dotted quarter note. And that means about 3 eighth notes would be about equal to 3 diameters around it. As I calculate this around and quantize it to durations that could easily be played, you get the rhythm on the bottom, which sounds like this. So now I have a musical system that accounts for pitch classes and durations. And just like Bach, Beethoven, and Brahms took a musical system from which to draw their material, I drew this material from this system to compose a piece. The piece I composed is for soprano and piano. The text comes from the one-line poem by the Romanian mathematician Florentin Smerendaki. It's called Introversion and reads, "Irrational pains are slapping my inner living being." I chose this poem because it begins with the word irrational. Pi is an irrational number. One reason I'm doing this flash lecture is I'm hosting a symposium on March 29th through 31st called Sound, Color, Shape. It's about our perception and how we seek to understand it. Your professors from music, mathematics, theater, history, English, basic biomedical sciences, and modern languages and linguistics will be speaking at this symposium. The keynote address will be given by music theorist Dr. Keith Selle from Shenandoah University. All events are open to the public and free. I hope you will attend. Thank you.